The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon. It's Mark from SolidCAM. I'm back. With me, as always, he's the reason the cookie crumbles, Kevin Rankle.
Hey guys.
Yes, I'm back with my cheesy intros. You guys had Kevin for 2 days, and I think it was yesterday's class. Kevin was sent this part. He forwarded it to me. And I believe the question was related to templates. So what we'll do for today, we'll start on this part, that topic of templates. If you have any questions, go ahead and put them in the questions panel. Actually, Jake is in attendance. Jake, I got a question from you as well. So if we have time, we can go to that question. But everyone else, if you have a question, feel free to put it in the questions panel. And if we don't get to it today, we can get it to it through the week or sometime probably next week. So today, templates. Templates is a very easy concept, and it's basically, you've done enough programming, you repeat it over and over again, why not save that and reuse it? So the way you do that is you add your toolpath. So let's just do a quick facing operation. So I'll use that to recognize my stock and my target. I'll just add a tool very quickly. Okay, so you notice, now you guys are all familiar with this, but you notice I'm entering in different parameters. I'm saying top of stock, top of target, giving it a step down. Everything I plug in here is something that is recorded by the operation manager for use at this time. But if I want to, let's say, use this again in the future, what I can do is in this menu, click on this save icon, save template. And I can save the tool that I selected. I can save all the parameters that I plugged into this window. So even, let's say, for instance, if under hatch, I find maybe it's not completing the toolpath, and I'd like to kind of, with this tool, over travel a little further, maybe go another 10% or something like that. Every prompt in this window, even the angle that I choose, maybe I want to put it as an optimal angle, is something that gets recorded by this toolpath that could be saved in a template. So if I go save, like I said, I can save the tool data, I can save all that information there, and then when I go to reload it, let's say I did a save, in my new part file, brand new part, I want to apply the same methodology of the face mill. I can right click, add operation from template, and then load the template that I put on screen here. And what it does is it imports all the information I told it to save. The only thing it doesn't save is the geometry, because by design, we're probably going to use that toolpath on a completely different part, so we're not going to save that geometry. You can do the same thing with templates for a group of operations. If I had a whole bunch of operations here, I can highlight all of them or highlight individual ones. And then when I right-click on it, instead of just creating a template, I can create what's called a process template, a group of operations. And that does the exact same thing. What it does is it saves the tools selected, it saves all the prompts in the individual toolpaths, and then when I load from the process template, let's say if I grab this one here that we did previously, I forget when it was, but it looks like it was on the 7th, you can see that it brings in all that information there. And then when I click OK, it's going to ask me for any information that is common between them. So at minimum, they have to be on the same MAC position. So that's why I have this ability here to choose it, or I can make one. Anytime you see a button that has those little 3 dots, it's pretty much going to load you somewhere else. Either define a fixture when you're in a machine setup, or to define a new coordinate system, or even choose new geometry if you're looking at a pull-down list of other geometries. So 3 dots usually browse to something else. But let's say in this process template, being a group of operations, they share geometry. Well, if they share geometry, then I would have the ability to define that geometry, a singular piece of geometry for all the toolpaths. In this case, it recognizes that they are different toolpaths completely, so there's probably no shared geometry. But a good example of this would be if you have a process template for a specific type of porting or a certain type of drilling process you want to follow. Spot, drill, tap, maybe there's a countersink in there somewhere. So those groups of operations, those would share one piece of geometry, that being the drill point. If you did maybe you had a company standard on how you'd like to rough finish and do floors of a pocket, Well, those would probably share the same pocket geometry. So good example of a process template is a group of operations that maybe are done to a single piece of geometry. You can choose here. But let's say you don't share geometry, but you definitely share an upper level. Well, I can check this box here and make them use the same upper level, or click on the 3 dots and then choose it from the solid. And then just preload all of them with an upper level, preload all of them with a lower level. But if they don't share anything, like I said, they at minimum have to share a Mac position. So I click OK. It adds those 4 toolpaths. And if we take a look at the color, basically those 4 toolpaths, the ones that are in red are looking for geometry. So they can exist on the toolpath window, but I can't calculate them, I can't G-code them because there's nothing there. There's only just a definition, the beginnings of an operation. If I go in there, I could choose the geometry and do a synchronize and calculate. The reason why the face mill of that process template is not, and I could just pretty much just go right into doing synchronize and calculate, is because that one had the box checked for automatic geometry selection or automatic reading of the top and the bottom levels. So the template used to be a great way to skip a lot of steps, but with now our new stock recognition and all kinds of new recognitions inside of the software, inside of the toolpaths, templates can take on an even more of an automated form, because now you can tell them to automatically look at the geometry, automatically read the top of the target, automatically read the bottom of the target, and you can just, once you bring it in from the template, synchronize and calculate. So it skips a whole bunch of steps. I'm going to hit cancel on this because it's probably going to go forever because I already did a face mill. So there's no geometry for it to recognize. Now, what you can do with these templates, we'll just wait for that to go, is it doesn't have to be an entire toolpath. You don't have to tell it what tool to use, offsets, angles. It could be something as simple as you'd like it to default to a certain strategy inside pocketing or a certain offset on the wall. Good example of that is there's some people that, let me just get rid of this on screen here.
And I think what you're going to say there, Mark, is just change up something very minor inside the operation. And we did cover that yesterday afternoon, changing up and changing it over as a default template.
Yes. So that's exactly what I was going to do. So if you guys already talked about it, I'll just briefly review it for anyone that wasn't in attendance yesterday. But in your part level settings, or even on your global settings, when you go to template, you can load those templates as well. So if you had a small minor change, like something like an offset that you'd like to default to every time you open up a particular toolpath, or even just a full toolpath, you want your face mills to always be done with tool number 1 or something like that. You can check this box, and then this becomes a preloaded template. Every time you load that particular type of toolpath, it will load that template instead of just the default. So that's another way to skip a lot of steps. Rather than opening up an operation and then trying to load that template from load template, you can actually just get it to be preloaded. So every time you open it up in your future parts, or every time you open it up in this part, that particular toolpath will preload to that template. So again, any repetition, anytime you're repeating a toolpath for different parts, templates is a great way to skip a lot of steps, or even to retain a design intent or a programming intent in your company. A lot of times there are customers that say, oh, we've got a new guy and he doesn't remember or he doesn't know how we do things yet. Well, there's a lot of ways where you can get your programming to always follow the same mode. Use this tool with this offset, with these fees and speeds. You can get the templates to record all that information for you, and then all it is just load and calculate.
And where I'll see, or what I'll do a lot of process templates is when you're doing tapping. So you get your spot drill, drill, tap, or a spot drill, drill, ream. A lot of those you can set up in there.
Absolutely. And another good example is if you're using a shape tool and it has to be offset and dropped in the tool vector by a certain amount, those are also parameters you're plugging into your toolpath. So if you guys remember, if you were in attendance when I was talking about that shape tool for that woodworking company that does the fancy railing, they had that contoured tool that needed to be dropped and offset by a certain amount for it to actually fit the profile of the target model. Well, all of that was recorded inside the template they were using. So they literally just had to load the template, choose the geometry that they wanted to use, and then calculate. They didn't have to remember how to offset that tool. So another good example. So anytime you're looking to save information that is the same every single time, but it's kind of a pain to remember it and load it in there and all that. I often tell people whenever they're calling and asking about reduction of cycle time or just efficiency of their shop, I always say, well, you're looking at the cycle time on the machine, but always remember that there's a bit of time on the programming side that could be saved as well, using templates, using iMachining, using all the other functionality inside SolidCAM. That can also eat up a lot of time, eat up a lot of capital, basically, because if you've got a programmer that has to sit there entering the information every single time, and he uses a template instead, that shortcuts it. Now, that's good for the boss side of things, but the programmer side of things, he probably would like to take his time and eat up some time, but that's probably just me back in the shop. Take some time. Oh, I got to take the time to program this. I got to go get some coffee, sort of thing. But anyway, so any questions on templates?
Nothing coming in yet.
Nothing yet. Okay, well, if you have any questions on templates, or if you have a part or anything like that going forward that you'd like to see how templates could be applied to it, or if you've got a procedure that you'd like to see if it can be improved by the inclusion of templates, either send us something like a part, or maybe send us an email with what you're trying to do and where you're trying to save your time, and we can probably cover it in a SolidCAM Live. If it's something proprietary, always remember that whenever you get into an online training with us, we can sign an NDA if you need it, or if it's just basically if you have an email from us that says we will not share this, then definitely in your online training, everything stays in-house. We never share with anybody. We never bring it into demos. We never bring it into these sort of things unless we get express permission to do so. So the other question we got was from our friend Jake, and he's basically looking at this part here. So here's the email. So I had a quick question regarding how some of the toolpaths are showing up on a recent project. These are contour 3D toolpaths. I'm guessing that the green means that the tool is going up or down, and that the yellow means that the tool is changing direction in Z. You can look at the screenshots below and see that what I'm talking about. Also, I don't think there is anything that couldn't be shared publicly in these images, so basically what I just said. So he gave me the permission, so we're going to show it. So whatever this is, looks like it's a three-dimensional a hole, basically, with if you look on the lower edge here, it does seem to change a little bit in elevation in Z. And Jake is correct. The different colors do indicate different things. So normally, the yellow would indicate a engagement of the tool. So that's a feed move engaging material. And the green, usually, if this was an HSS toolpath, I would say the green is basically a feed move non-contacting with the material. Oh, and Jake is saying that this is a path for trimming vacuum form parts. Perfect. Okay, so that's kind of what it looks like from this angle. It looks like it's a very thin part. So if it's vacuum formed, that's in my wheelhouse. I used to do that sort of thing. But it is exactly like Jake says in his email. When you define a tool, you give it a color. So for instance, this tool that we have here, most of them were defaulted to the blue, but if you look at my tool 2, it has a color of this orange color. So if you take a look at the tool paths being used, let's say we have this tool 1 here. I'll change the color to something we're going to see. Let's make it that orange color as well. When you look at your tool path, the wireframe, you have basically 3 colors that make up your wireframe. The color that you've defined for your tool, so in this case I have this kind of darker orange color, that's my engaging material feed move. The green move is a feed move as well, but away from the part. It's non-engaging, or at least that's what this thing is assuming by its stock definition. And then your red color is your rapid. And you can see here from the beginning here, we start from a red ball, we wrap it down to the clearance plane, and then there's a little bit of a green there where it's feeding down to the final position, and then it begins its actual engaging material orange move. So going back to Jake's email, we can tell from here that at this point it starts here, it kind of rapids down a little bit, feeds down, and then the yellow is engaging. Now in the Contour 3D toolpath, it's representing those colors just like we described. But with Contour 3D, it's a little different than something like HSS. In HSS, you will definitely see the different movements of material engagement, feed move, non-engaging, and then rapid. With HSS, it's a really good example of those different colors and what they mean differently. With the Contour 3D, it's a little different. There's a lot of stuff going internal that is accounting for this. If we didn't see the colors on this, we would think this is a nice smooth toolpath, and it is. I mean, if Jake in the questions panel, if you've actually cut this material on the machine, let us know if it actually did look as smooth as it looks here, because it looks like this would generate as exactly as intended, just a nice spiraling toolpath going down. Now, the fact that it's a green versus a yellow probably just means that the Contour 3D did something at this point here where somehow the calculation thought it was non-engaging or something like that. But like I said, it looks like a nice smooth toolpath that's going to do exactly what it intended. Let me see Jake's question here.
And if you guys kind of remember what we were talking about on Friday when we were using that HSS and when we were skipping over those holes, it was actually showing green, and it's still cutting. It's just it could see a gap along there as well. So I'm guessing with the Contour 3 is there's just the slightest little gap, and that's why it's triggering the toolpath simulation to treat it as almost like a gap in HSS, but even though it's not.
So was that a gap along the cut follow surfaces that you're talking about?
Yep.
Yeah. So that's exactly what you would see when you use HSS, because if you engage, I haven't had a chance to watch the video, but the video is on the YouTube channel. But in HSS, it's a great example of what this means, because on the model, it might have a hole in it, but at the point in your toolpath, if you haven't had a chance to remove that material and you're going to do a gaps along the cut follow surfaces just to account for that, the wireframe will still show it as green. Like Kevin just said, it's skipping over that gap by doing a feed move. In reality, it's cutting material, but in the toolpath, it's just assuming that it's jumping a gap, so it gives you the green color instead of, in this case, the yellow color. For Contour 3D, it's like Kevin said, it might be doing something like jumping some sort of a gap, or maybe internally it's filling the gap somehow. There's something about this 3D movement that it thinks it's accounting for it somehow. But in reality, it does cut it nicely, or at least it looks like it. And then Jake has a comment here. The tool should be engaged along the green and the yellow portions of the toolpath. That's what it looks like from this wireframe. So if that's how it happened on the machine in real life, then hopefully Jake can tell us that. But basically, that's what that should represent. The fact that it's a nice smooth toolpath and it actually is continuing that movement there. With Contour 3D, you can also see that it is actually following that kind of gradual dip and then back up. So that is the purpose of Contour 3D. And in order to do that, I wouldn't be surprised if it does have some sort of internal logic where it kind of modifies it like that. Okay, so we have some time left. Any questions on this? Any questions on anything else that has come up?
Mark, do you have the training files for the 2.5D from the site?
From the site? Probably not. Let me just check. Possibly, but
maybe
rather than looking for it, let's go to the website. Let's just go to the site and show people how to get that.
Because there's one that kind of shows that pretty much exact same thing as what Jake's doing there.
So that's documentation?
Yep. And the milling, and do the exercises for the 2.5D. And then it's going to be under the built parts. And we're just going to have to kind of go through the built parts real quick to see which one it is. I want to say it's exercise 12 or something like that.
I guess it doesn't show. Okay.
Do it through SolidCAM.
And if you guys weren't aware, you don't necessarily have to close your files anymore and open up a new file. They've changed it so you can actually just go and try opening up a new file, and it'll close it for you.
As long as Mark can find where he put his folder.
Yeah. I did extract. There it is. Okay. So number 12.
No, it should look like a mouse with a hole in it. There you go, right there. So here's our 2 contour 3D pass. Go ahead and just turn on those pass. And like to Jake's point, you know, he's definitely making a very good, valid point that the colors are changing. But I think it's just something to do with just that contour 3D. And I just wanted to verify that real quick to make sure I was telling you guys the right thing here. But so you can see the, you may have to go to the configurations and turn on the default, so we can see that inner one. So you can see, you know, halfway through the circle, it is yellow, and the other half of the circle is green, which, like Mark was just telling you guys, you'll still get the exact same toolpath as you're looking for. It's just how the wireframe is looking at that physical geometry. So tool number 1 is showing up as yellow, and tool number 2 is showing up as purple, but you'll still see half of that model is purple and half that model is green. So just somehow something to do with the built-in algorithm. And if you want, Jake, I can turn that into development and see why it's doing that, but just something to do with that particular contour 3D, and it's the only one I ever see it on.
Yeah, I've never seen it anywhere else where it doesn't indicate the specifics like we were talking about, but you'll notice from the Solid Verify that the tool colors are still engaging the material. It's still doing what we intended to do. So that green color, I don't know why, it's something internal for the calculation, but you can see that it actually is doing exactly what we were told it to do, and it colors the Solid Verify with that single color, not the green. That's kind of interesting there, but that's a good part. I always forgot about these build parts.
Yep.
So Jake's just saying he just wanted to check he wasn't doing something wrong. Absolutely. Anytime you see something weird and you want a little bit more information on it, not only do we do tech support, troubleshoot kind of stuff, but we're here to answer your questions as well. Not everything has to be a SolidCAM Live, KevCam, online training. It could be just simply, hey, what is this? And then we can spend 2 seconds with you on the phone, you know, answering questions. If you can't find it on the YouTube channel, the website, the documentation, there's many of the help menu. There's lots of different places to look for that. But absolutely, if you have a quick question, no shame, no problem, just give us a call and we can answer that question right away. Okay. So any other questions on this or anything else?
Don't see anything.
Okay, I see that is it Stellian Bot? Yeah, okay. So I think that's the guy that sent you the part. So since he just came in, I don't know if you've been here the whole time, Stellian, but we were talking about your question. So if you want some follow-up, email me. Kevin's going to put my email in the chat, and we can talk a little bit further about specifically what you wanted to do. Okay, so he was not. Okay, so basically, in terms of templates, this video will be put on the YouTube channel. So once Kevin does that, you'll be able to see it on the YouTube channel and see a little bit more of what we talked about with your part with templates. But if you're curious, definitely email me, and we can set up some time and we can go over your part, specifically what you wanted to do with this part. And that goes for everybody else. Remember that there is training available. If you don't already have time on the books, contact your local salesperson and just see what it would take to get you into training. Online training using GoToMeeting directly over the phone, so you can ask your questions live, either with myself, with Kevin, with anyone else on the team that you feel you've got a good rapport, or if it's something that you need specific help with and you want that that direct expertise. Every one of us does have a little bit of extra experience with something than the other ones don't. So if there is something that you need a little help with, definitely we would get that expert engaged with you. In addition to that, if you know anybody that could benefit from SolidCAM, I know I say this, but it is true. We will give you a finder's fee, and I think it's $100 right now for just the SolidCAM Live KevCam promo kind of thing, where if you put someone in contact with us or our salespeople and they get into a demo, you get that gift card. If they go to sale, you get a percentage of it. So it's to your benefit to not only use SolidCAM for your own business, but if you've got someone that could benefit their business. Or, hey, maybe you don't want them to be in the business of using SolidCAM because then their cycle time is the same and yours gets reduced. We do have people that do that where they don't want to, flood the market with a good product like ours. But hopefully you have some friends that you don't want to disrupt their business. But okay, so let's see. There was some final questions there. What's your favorite Pauly Shore movie?
Who's Pauly Shore?
Pauly Shore was a MTV VJ. Did you guys call them VJs? I know we call them VJs up here in our music television thing, but Pauly Shore was that really like California kind of surfer dude kind of guy. I would say, I think Encino Man. Pauly Shore was in Encino Man, I think, right? Either that or like.
You're not talking to me, are you?
No. Well, you know what? I'm just talking to Jake. Me and Jake are having some movie time, Kevin. Okay. So, and Brad is asking, where can I find these videos? You can find them on the YouTube channel. So let's go to YouTube, SolidCAM University. Now I'm subscribed. I want to see Kevin's face every time I open up SolidCAM.
Yeah. Everybody got to see too much of my face on last Friday by accident.
But what you can do is you can go to YouTube, youtube.com, like always, and then in the search bar, type in SolidCAM University. There is other YouTube channels related to SolidCAM. There's SolidCAM Professor, which is done by Sydney. He's been doing it for years before Kevin and I were probably even born, sort of thing. But he was the SolidCAM Professor. He's got lots of videos, but he has since moved up in the company. So he no longer does these direct videos. He will host some of the webinars, especially some of the ones you see on our YouTube channel as well. But he no longer does videos. So if you do find the SolidCAM Professor videos, they're usually from maybe 2013, 2014. I think Kevin and I have been doing this since 2015 probably. So you'll see more up-to-date videos. That being said, if you find a SolidCAM Professor video, it's not necessarily incorrect. It just means that it's an older version and there might be newer buttons, newer interface. So if you're looking to see videos on 2020 or 2019, depending on which version you have, you'll find it on SolidCAM University. There's also, I think it's called SolidCAM iMachining, I think. There's lots of different YouTube channels, but the one that I would direct you to is SolidCAM University because that is where the SolidCAM Live videos, as you see on screen, are uploaded. So you can see that Kevin's videos from yesterday and Friday are here. All the other ones that we've been doing together in the past couple of weeks are here, as well as some other webinars that have been released to Kevin.
Let me ask you guys this. I know we have quite a few people in your attendance right now. So you guys see the What's New SolidCAM 2020 simultaneous 5-axis part 1 through 5. Do you guys like seeing those videos? That was actually done by one of our other SolidCAM team members. But do you like seeing those ones in there, or should we just leave those out? Because I have a whole pile more to throw in there if you guys would like to see them. Yes, okay. I'll get uploading those right away for you guys as well.
Yeah, absolutely. Those are a little longer, but we watch every single one because those are basically internal ones and external ones. So there's a lot of good information there that if you end up using the 5-axis, you will see some benefit, especially number 3. I was really impressed with number 3, how we can do a part like that using the automatic gouge protection. So if there's any one of these I can recommend, it's number 3. But also, I know this one too. This one was insane how he did this one. That was pretty cool. But every one of these videos is to your benefit to sit through. And what I normally do, and this is a trick that I do to watch every single one of Kevin's, is let's say for instance we go with this one here. well, obviously this is mine, but if I want to rewatch this or watch something I haven't seen, and I discovered this earlier this year, this little gear symbol, you can watch this at double speed. So if you want to watch this, but you want to just get the gist of it, you don't want to wait forever, you can watch it at double speed, or maybe 1.5 if I really want to understand what's being said, and then you can watch it in half the time, or 75% of the time. So that's another trick.
Sounds like a chipmunk.
Yes, it does come out like that. But I mean, if you were looking to just see what buttons he's clicking on or what steps he's taking, definitely you can watch it at extra speed, because for instance, let me just mute this. I can watch this in half the time, and I'll be able to see exactly what we clicked on, what inputs we put in. So it's a way to kind of watch these videos a little faster. That's not a SolidCAM tip, that's a Mark tip.
And make sure you guys subscribe to it, because my only goal of creating this YouTube channel is to beat Sydney in subscribers. So if you guys are watching this or sitting in the class, make sure you subscribe. And maybe I'll update the SolidCAM University picture to have one of our customers, Brad Denton, and I at a trade show together. Maybe I'll put that up there for everyone. As Brad writes, never happening.
While we're here, let me just double check. If there's any other questions, please ask. But yes, Pauly Shore was in Encino Man. There you go. That's for Jake. Okay, if there are any other questions, Kevin has put my email in the chat section, I believe. Yes. So any questions, go ahead and send me the question. You can send it to Kevin as well. If you have parts that you don't mind being shown in the show, please send that to us and we can go over your part. And like I would say, if you're looking for direct personal training, you can use my email as well. I'll put you on my calendar or on the calendars of anyone else on the training team, and you can do live go-to-meeting training with anyone on the team. We will be continuing this for the rest of the week and up until, I believe, the end of June. So you'll have plenty of opportunity to get your questions answered if we didn't do it today or whenever you submit the questions. But for now, we'll end the session. Stay safe, keep your family safe, keep busy, and we'll talk to you guys tomorrow.
All right. Have a good one, guys. Bye-bye.